Hello, this is Mrs. Edwards. Welcome to the review and preview for the CCG book, numbers 840 to 846. 8-40 says, Esteban used a hinge mirror to create an equilateral triangle as shown in the diagram below. If the area of the shaded region is 11.42 square inches, what is the area of the entire equilateral triangle? Well, we know that all of the triangles within there, if we reflected them, are equivalent because it is an equilateral triangle. Therefore, we can take 11.42, multiply that by 6, which will tell us that the area of the entire triangle is approximately 68.52 square inches. (8-41) A house purchased for $135,000 has an annual appreciation of 4%. Question A says, what is the multipliers? The very first thing we need to do is we need to take 4% and change it to a decimal. So our decimal, we want to move 2 jumps to the left, so we have 0.04. But our house is appreciating, but we want to take into consideration the original purchase price of our house of $135,000. So we need to add 0.04 to 1, which gives us a multiplier of 1.04. So if you remember back to Algebra 1, when we have numbers greater than 1, we are going to get an exponential increase or growth. Question B says, write a function of the form f of t equals ab to the t power that represents the situation, where t is the time in years after the house was purchased. So we are working with an exponential function here. So a in our exponential function represents our 0 term, and b represents our multiplier. So we already found our multiplier in the previous question, so we have 1.04. We know that our original purchase price of the house was $135,000. We want to leave this in terms of t, so f of t, because t represents our number of years, would tell us how much the new price of the house is. At the current rate, what will the value of the house be in 10 years? So we are going to replace our t, or our time, with 10. We're going to follow our order of operations when we type this into our calculator. So we get our house is approximately worth $199,833 after 10 years. 8-42 gives us a bunch of shapes and asks us if the shapes are convex or non-convex. So remember, convex means all of our lines are pointed out. And non-convex means that some things could be in. So when we look at letter A, we have this vertice where we have 2 sides connected, and it is towards the inside of our shape, so A would be non-convex. All of our vertices are pointing out on B, so we'd say convex. Same with C, convex. And then we notice this vertex is on the inside, so we would say D is non-convex. 8-43 asks us to find the areas of the figures below. So looking at our figure here, the first thing that comes to my mind is that I could extend this in order to make it an entire triangle, telling me that 9 minus 5 would give me the distance of 4 right here. but then we don't have enough information to determine what this piece is. So back to the drawing board, can we create some other shapes in order to find the area of our figure? So knowing that 9 minus 5 is 4, we can say the area of this piece is 16 units squared. If we know that our hypotenuse is 4 roots of 2, and one of our legs is 4, we can use the Pythagorean theorem. A squared plus 4 squared is equal to 4 root 2 squared. So when we do 4 root 2 squared, we do 4 roots of 2 times 4 roots of 2. Multiply what's on the outside. 4 times 4 is 16. Square root of 2 times square root of 2 is 4. 16 times 2 is 32. So 32 is equal to 16 plus a squared. Subtract our 16. A squared is equal to 16. We get a, or the missing side, is also equal to 4. So we then at this point have enough information to say that this side of our triangle is 4. So the entire side of our rectangle would be 8. We could do 9 times 8, which equals 72. We would need to subtract out the area of this half of our triangle. So 1/2, 4 times 4, half of 16 is 8, so 72 minus 8 would tell us that the area of our shape is approximately 64 units squared. So remember, there's lots of different ways to do that, but that is just one way. Looking at the next problem, we know that we are looking at an isosceles triangle, and the top angle is 22 degrees. So if we take 180 and subtract 22, we know that this angle becomes 11, which would give us a right angle here. We then could use right triangle trig to find the height of our triangle and the base of our triangle. So this side is opposite, this side is adjacent, this side is our hypotenuse. So what uses our SOHCAHTOA, what uses our opposite and hypotenuse is the sine. So the sine of 22 degrees is equal to our opposite side over 12. Multiply by 12. Make sure that your calculator is in degrees instead of radians. So 12 times the sine of 22 degrees is approximately 4.5. So this piece of our triangle is approximately 4.5. We can then use cosine to find the height of our triangle. So the cosine of 22 degrees is equal to our adjacent side over 12. Again, 12 times the cosine of 22 gives us approximately 11.13. So if we take the height of our triangle times the base of our triangle, or in this case, if we took this piece of our triangle and flipped it over here, we could take 4.5 times 11.13, which gives us approximately 27 units squared for the area of our triangle. When we're looking at example C, we have The base of our triangle is 4. The hypotenuse is 8. 4 squared plus our missing side, we'll call it b squared, is equal to 8 squared. 4 squared is 16. 8 squared is 64. 64 minus 16, using inverse operations, gives us 48. When we take the square root of 48, we get approximately 6.93. B is about 6.93. We then can take 1/2 of 6.93 times 4, and we get our area to be approximately 13.9 units squared. 8-44 says find the number of sides in a regular polygon if each interior angle has the following measure. So if we have an interior measure of 60 degrees, remember the interior of our polygon is equal to 360. So 360 divided by 60 tells us that we have approximately 3 sides to our regular polygon. If we have an interior angle of 156, so looking at example B, if we are talking about our interior angle being 156, we know that this angle plus this angle has to equal 156 degrees. We subtract 156 from 180, which tells us our central angle is 24 degrees. I know that my central angle, or my circle, adds up to 360 every time. So 360 divided by 24 will tell me that I have approximately a 15-sided polygon. When we look at our interior angle and know that it's 90, again, I know that both of my base angles add up to equal 90. So if I subtract 90 from 180, I get 90 as my top angle. 360 divided by 90 tells me that I am working with a 4-sided polygon. Again, I have 140. If I subtract that from 180, that tells me that my central angle is 40 degrees. 360 divided by 40 tells me that my figure is 9 sides. So looking at 8-45, it says determine if the figures below, not drawn to scale, are similar. Justify your decisions. So this is a perfect opportunity to use the e-tools within the homework. And if you click on the e-tools, it will bring you to all of these colored circles, and then you can click the colored circles to adjust them. And you will notice that by transforming, the similarity of the circles are all the same, so all the circles are in fact similar. And you may remember from earlier this year in problem 3-55 that all circles are always similar. 8-46 below is a scale drawing of the floor plan of Nzinga's dollhouse. The actual dimensions of the dollhouse are 5 times the measurement provided in the floor plan. Use the measurement provided in the diagram to find the area and the perimeter of her floor plan. So remember, to find the area, we can cut this up into smaller pieces, and to find the perimeter, we're going to add up all of our sides. If we know that this larger side is 9, we can subtract 9 from 12, and we can get this little piece is 3 centimeters. That also tells us, if we trace that over to here, that this piece is also 3 centimeters. If we know that our larger side is 20, when we subtract 8 from 20 and subtract 4 from 20, we get this piece to be 8 centimeters, and we now have all the dimensions to find the perimeter. So the perimeter, we take 12 plus 20 plus 9 plus 8 plus 3 plus 4 plus 6 plus 8, which gives us approximately 70 centimeters for our perimeter. When we find the area, we can take the area of the smaller pieces. So we have 12 times 8 plus 4 times 3. So this dimension, if we subtract this 3 from 9, gives us 6. So 4 times 6 plus our last side is 8 times 9. When we multiply those together and add them all up, we get an area of 192 centimeters square. Draw a similar figure on your paper. Label the sides with the actual measurements of Naziga's dollhouse. What is the perimeter and the area of the floor of her actual dollhouse? Show all your work. So if we draw this figure again on our paper, it said that her dollhouse is actually 5 times the measure. So if we multiply all of these measurements times 5, we would get 60. 20 times 5 is 100. 9 times 5 is 45. 8 times 5 is 40. 3 times 5 is 15. 4 times 5 is 20. 6 times 5 is 30. And 8 times 5 is 40. So we would get a perimeter when we add up all of our sides of 350 centimeters. For the area, when we now multiply these pieces together, 60 times 40 plus our rectangle in the middle, which is 20 times 30 plus 40 times 45 would give us an area of 4,800 centimeters square. Find the ratio of the perimeters of the two figures. What do you notice? If we take the perimeters of the two figures and we put 350 over 70, we notice that the ratio is 5 to 1. So it is a zoom factor of 5. Find the ratio of the areas of the two figures. How does the ratio of the area seem to be related to the zoom factor? So when we take the areas and we put 4,800 over 192, we notice that we get 25 over 1. And if we compare these two numbers, 5 and 25, we should notice that the ratio of the area, so the ratio of the area equals the perimeter, 5 squared. So we would say that it is a zoom factor of 5 squared.